You okay with that?
Sorry, it's 1.5 idea loss.
All right, so first thing we have to do, we have to get a piece of homework I gave you, a graph to finish out, right? Last time we started kinematics, we talked about velocity, acceleration, and equations of motion, right? All right, so last time we talked about some graphs and so on, right? So while we were talking about the graph, I asked you all to finish off. Right, yeah. So this was missing. You had to take the information given and sketch the graph. Now, anybody did it? All right, so now take some of my time. So I'll probably push it to 9 o'clock now. All right, try it, please. Go back to this. Go back to this. Take the information and sketch the graph. Well, I'm taking up my time here. My kitchen time is probably 9. Half is the graph. Huh? No, try it. I want to try it. Right, take the information here. A to B, B to C, and so on. And here as well. Take the information and try and sketch the graph, right? In the handout on page 20. Anybody did the homework online? Let me see. Who have the counts on to do the homework? To be sure. You did the homework? Anybody like, it's nice, yeah. Sure, nice, yeah. Right, so I want you to plot the graph based on the information given. So open the handout out. Right from A to B. Look at this image. we remember from last week, what is the difference between increasing gently and increasing uniformly? Right. Gently is a slight curve, right? A slightly increasing curve, and increasing uniformly means straight line. And then decreasing, how will that look? No, decreasing on this. Remember, we're doing distance time graph. How? Curve was straight line. Curve, right? It's curve. It's uniformly or gently. Did I say decrease velocity? Right? The aperture gradient decreasing. The aperture gradient decreasing. Then this said d to e, the velocity is 0. Right? D to e, the velocity is 0. D to e, the velocity is 0. And then, right? How you show that? Horizontal line, right? Horizontal line. Continue. And then it says e to f, the velocity is negative. How you show that? Change the direction, right? They decided to go down a little bit. But they said e to f is negative and slowly increasing. So whatever gradient, right? You're showing your slope, but it's here. Right? So you're showing your slope starting to increase forward. It's gonna be like this. You're showing your slope starting to increase. Okay. So you're changing direction and your slope starting to increase. Right? This is decrease. Well, sorry. This is decreasing. Right? So E to F is negative and slowly increasing. F to G, the velocity is negative. So what you'll do? Straight line because it's uniform, right? F to G, the velocity negative. F to G, the velocity is negative. A straight line. Well, a slope, right? Now horizontal line. Try the last part. Next part is that where we reach G to H. Yeah, I think we reach G to H now, right? Displacement negative. So what I mean? Oh, displacement negative. And right below the x-axis now. Yeah, so it means that you're going in on the opposite side of where you start, right? Yeah, going to draw it away. You try it still. Sorry, I don't draw it just now. Right, G to H is below the x-axis, right? And the velocity is negative, right? And uniformly increasing, so that we have straight line. G to H is a nice straight line below the axis, right? And then we have more H to I. H to I, the displacement is negative. Yeah, next side, HI. HI, the displacement is negative. Velocity negative, gently decreasing. Pipe joined up. Right. Nice slope. Nice slope. Just now enjoy the one liner. Oh, yeah, we're still here. You never in this class. Still here for me beginning too. Yeah, very nice class. Right, and H to I, we just did H to I. So we reach I to J. I to J, displacement is negative. And velocity positive. So what will happen now? It start to curve upward. Please remember there's a displacement time graph again on that front, right? And then last one, G to K, displacement is negative and velocity is increasing and becomes zero. Right, so we're going to try to get a shape here. Right, online. So take a look here. Let's check out what this time. A to B, the velocity increasing gently. It's not uniform, so that's a get curve, right? So here's A increasing uniformly. Sorry, gently. Gently. So we start here, that's B. That's a little curve. B to C, they said uniform, so that's a straight line. Then they said C to D, it starts to decrease velocity, technically decelerating. So decrease velocity in your mind, think of the gradient, right? Gradient increasing and then decreasing, right? So this will show a decrease in velocity. That's D. Then D to E, the velocity is 0, so that's a horizontal line. Then they said E to F, the velocity is negative, so it start to change direction now. So instead of going in this direction, change direction. So you have to have a negative gradient, so that'll be going down. Right? E to F velocity is negative and slowly increasing. Right? So this is slowly increasing. Right? Slowly increasing, right? E to F. F to G, the velocity is negative, uniformly increasing. F to G. Remember, this doesn't mean that you stop moving. This doesn't mean that you stop moving because this is displacement. It just means that what? What does G mean? You reach back to your starting point. Very good. You reach back to your starting point. A, B, C, D, E, F, G. G to H is what? The displacement is negative and the velocity negative. These are displacement time graph. So the only way to show displacement negative is to come down here. Is it uniform? Yeah, uniform. G to H. Okay. And then H to I, the displacement is negative, velocity negative, and it's gently decreasing. So this is how you show decreasing. Decreasing means it's going back to equilibrium, right? Means it's going back to where the gradient is 0. Remember the gradient is 0 right here, right? That's H to I. What's the next part? H to I. I to J. Displacement is negative and the velocity positive now. So I'm going to change direction and it gently increasing. So I'm doing an increasing gradient. That's a curve. That will take you to J. J to K, the displacement is negative. Velocity becomes 0. Right, so you're going right back here to S. Right? Actually, because the velocity goes to 0, I shouldn't draw it like that. I should draw it more like this. Right? This gradient going back to 0. Hij. All right? So that was the homework class. Now we're gonna start. That was the homework here. The only straight line part is here, here, and here. Everything has curves. Everybody's seeing why this is decreasing, right? Pardon me? Why is it not like this? What does this show? Whatever gradient you have here. Any gradient here? Small gradient here, right? And it keep increasing. What about here? Think of the gradient here. Gradient is tangent at that point. Gradient is 0 here and it's increasing. But if you draw a line this way, gradient increasing, gradient big, gradient getting small, and when it reaches here, it's 0. So this is decreasing gradient. Right? This is increasing gradient. Okay, so you want your shapes to show that. Remember, you all initially would have done straight lines, and now we include curves. All right. So that is the displacement time graph. What you were supposed to do was the velocity time graph. I do not want fair way to do that. And I have to. I will try that. Right, let's go to the velocity time graph. I want a little bit. And then today we're doing projectile. Right, as a quick review, remember the velocity time graph, the gradient is acceleration, right? And the area under the graph is displacement. Right, same thing. Right, and they give you all the information there, A to B, B to C, and so on, right? It's ready? Oh, yeah. Yeah, well, that one will tell you, you know, much. Huh? Because that A to C. No, that's summarized. A to B, B to C, then the proceed to D. They summarize A to C. If you read the next part, you will see that. No, sir. Yeah, think about error. Because the third one is what you B to C. Third one. No, the third one just combine what happened in the B. Alright, so why are you doing it? Let me do it together one time. Right, well, you can see that ever. Right, first thing first, gradient constant. I can't do it right here, right? Gradient constant and acceleration constant. Object accelerates from rest to B. So that's straight line, right? A to B. B to C gradient decreasing and velocity is still increasing at a lower rate. B to C looks like that. Two, right? C to D gradient is zero, velocity constant. Right, so I have to do that. I have to reach D. Go to the rest, go to E, F, and G. Right? Try E to F. E to F easy, right? What that means, what happens D to E? Oh wait, I'm missing one. Roll D to E or I'm missing one. Negative acceleration. B is positive, so right, so D to E is a straight line like that. Right, it says D to E constant gradient, so the straight line. A is negative, so that means the gradient has to be negative. B positive, so it's still above the x-axis, and B. No, and then F, E to F. Okay, but F is probably other way, so let's go down there. Right? That's F somewhere down there. E to F velocity, oh, rest, okay, yeah, sorry. I know we did it. So D to E is all the way down here. E to F is what? At rest. Are you sure you're not rest? Okay, that's going to be a straight line right there. Because D to E was all the way down to rest. Right? Sorry about that. Finish up F to G. G to H, H to I. Right? How you join F to G? Constant gradient, constant acceleration, but the velocity negative. Straight line comment up, right? That's the G. Right? Two more. G to H, H to I. Right, let's see, G to H gradient 0, so that you see. And H to I gradient constant. Back to. Also, that's your thing. That's your thing. Yeah, uniform. Right, area underneath here A1, area underneath here A2. What's the total distance traveled? Right. A1 plus A2 is total distance traveled. Shivish, what's the total displacement? Sorry? What's the total displacement? What would the total displacement be? Eight I. So like how, look at the total distance. A1 plus A2, right? Yeah, add up total distance covered from A to E, and then cover the total distance from F to I. But what's the total displacement? 0? Up? A1 minus A2. What happened during A2? Remember the velocity change. If the velocity change, there's a chance to change that direction as well. Right? So your total displacement will be A1 plus, well, negative A2. Okay? So the change in direction. Sorry? Well, A1 minus A2. I just write plus minus. Okay? So those are the things that we need to know about the graph, right? Those are the things that we need to know about the graph. All right. Before we move into projectile motion, remember online we go till 8:30, right? I'll give you all a break around 8:30. Around that. All right, so the next thing I want to take a look at, before we do projectile motion, I want to go and do some questions on equations of motion. All right. So I'm not sure if you're read up on these, but let's take a look at this here. First thing first, let's write down the equations of motion, and then let's go over some of the questions there. Where should be? Come. What's the last week? Okay, remember after the proof. I know I will just write down before. Right, so it's equal to write the equations of motion here.
How much? It's four. Four. It's four. I learned farm by four. I actually. Am I going correct?
Yeah, that's how. Right, I'm on.
Você velocity no set, right? Is it fine?
B minus C, right?
Yeah. I like to. I discuss my project.
Equation of motion.
Yeah, I listen.
Go ahead.
Where is home? So what exactly you want me to do?
Just write the equation.
No, it's not happening. Visual. I get in trouble, remember? But that's not me. Thing I heard is like 4 times this. I can't average it. Sorry, I need to.
B plus U.
Yeah, for this one?
Yeah.
Yeah, I know. Yeah. I was just checking if it was leaking or not.
All right, so we have the equations of motion, right? So we have V is equal to U plus 8T. V squared is equal to U squared plus 2AS. S is equal to UT plus a half AT squared. These three equations all have acceleration in them. So once acceleration uniform, we can use any of these. This one here, we hardly ever use this. U plus V by T or V on T, right? There's not really an equation of motion, right? This is the normal speed is or velocity is displacement on time. All right. So these are the equations. How do you know which one to use? To figure out which one to use, you have to look at the quantities they gave you. All right. So let's do the first question from the little handout there, right? What was it again? So a particle is projected. All right, let's start with one, right? So I'll give you an object. The object, right? The object starts at rest. This one's simple, is just like getting hang of what we're doing, right? The object starts at rest, and 5 meters later, at the point A, the object is traveling with a velocity of 4 meters per second. No, make up this one. All right, so let's say we have an object, right? Let's say we have an object, the object starts at rest, and the object moves to the point A where the velocity is U, where the velocity is V, right? And then from here, travel with a constant acceleration to the point P. Right? Let's see if we can find X here. Let's see if we can find X. That's all. I'm going to put some more values here. I'm just putting some more values in here, right? All right. So let's see if we can find these things here. Right. We have information. Right. So here's what we have. Object starting at O, it traveled 5 meters to A in some time, and it reached a velocity of 4. Right? Then from A to B, it had a constant acceleration, right? It had a constant acceleration where it took 5 seconds to reach from here to here, right? We have to find time A, the acceleration, oh sorry, that should be X. We have to find time A, X, and PB. All right. So first thing first, let's see if we can find the time for E. What do we have here? We have S, and we have starts at rest. So we know the initial velocity is what? Right? So we have U, we have S, we have V, and we want to find T. So which equation we could possibly use there? V is equal to? No, it reached a velocity here of 4. It wasn't constant. It was 0 and it reached a velocity of 4. So which equation we could use? So part 1, let's write down what we have. We know the initial velocity is 0. We know the final velocity is 4, and the displacement appears to be 5. They want us to find T, right? The time it takes to travel from there to there. Shania, you not seen it? This here? Don't see that. You want to find TA, X, and PB? Right. So which equation here we could use earlier? Which one? The fourth one, because we have U, we have P, and we have S. Right? So based on the quantities that we have, we can't use anything with A in it because we don't have A. So we have to use this one here. Okay, S is equal to half U plus B by T. So you're going to use that equation. S is equal to a half U plus B by T. And solve for T from out. Work it out, solve for T. Hold on. Yeah. Yeah. All right, so S is 5, a half by 0 plus 4 by t. A half of this is 2, carry across that, you'll get t is 5 on 2, which is 2.5 seconds. All right, part 2 now. We need to get x. X is a displacement, right? How are we doing that? I didn't give you a final velocity. So what do we have? We have a time. And we have the initial velocity now. From here to here, this becomes the initial velocity. So we have the initial velocity, which is 4. What else we have? We have trying to find acceleration. We don't have acceleration, but could we have found the acceleration? Because from here to here, constant, right? So if we know the acceleration it takes to reach here, we could find that, right? So yes, we could find acceleration, which is v minus u over t. So the final velocity here was what? Initial was, and time is from time, right? Time from here to here is 2.5. 4 minus 0, that's a 4. 4 minus 0 over 2.5. What is that? 1 point? Right? 1.6 meters per second. So now we know u, we know a, we know t. How are we going to find x? V squared is equal to u squared plus, because we have, well, we do have v. Yeah, we do have v. That's very good, right? Because we have u, we have a, and we have t. Right? So we have u, we have a, and we have t. So we can solve for x. Right? That's basically how you use the equations of motion. You'll notice you can't use the first 3 unless you have acceleration. Okay. Anybody answer? Okay. Right, work out for, well, for S. So we're going to use S is equal to ut plus a half at squared. So work out for S, tell me what you get. And then do part 3. Try part 3. Last one.
You want to turn it off to school, exactly, I think you might come out of there.
All right. Hallelujah. Yes, something keep in mind. Very good. Anybody else can problems seeing the working answer? How much you all got here? Right? 40 meter. And last part 3. They want us to find PB. What do we have? We have B, we have A, we have 10 things. Right? So we could probably even use any equation there, but because we didn't touch, huh? You can use the S&P for the half. Yeah, you can even use all that. But we can use the first one. Or we could use B squared is 2AS, right? I use the second one. We use it there? Or we use one, which one hard? Oh, you're kind of blurry, Amelia? Yeah, Shania said it's blurry too. Yeah, probably not. Huh? Yeah, you okay? Yeah, so it might be your internet earlier. Right, so B is equal to the square root of 4 squared plus 2 by E. I 1.6 by 40. What is that? 12. Right, 12 meters per second. How you're showing on Destiny? Superior? How the whiteboard showing here? Are you good? No, you can. All right, let's go again. Let's go again. Take a little read. Right, so they give you a particle that's projected vertically upwards. Right, so now we're going upwards, right? Here was horizontally, here we're going vertically. So, all right, so once you're moving vertically, you must have gravity, correct? And if you have gravity, you have acceleration. So most times we use an equation 1, 2, or 3. All right. Go ahead, try that fast. Huh?
then you initial velocity is 0.
So it was projected with the velocity of the when you start from right. No, what is these?
We can't use these squares equal to u squared plus 2j.
We are getting maximum height. No, think about what is happening at maximum height. Huh? Yeah, the height will be this part. Yeah. What happens at maximum height, Olia? Velocity is zero. And so it's something which is maximum height, the velocity is zero.
So we can
Right?
use squares equal to u squared plus 2j.
Because the final velocity is zero. Okay? The final velocity is zero. Light on? Big light on. Right, so remember that the initial velocity is 50 and the final velocity is 0.
We minus.
You're not minus up there. Because gravity going upwards as well.
Oh. No.
Right, all those things make a little note of it, right? Gravity going upwards, downwards, positive. Are you number A, B, and C? Right, but the equation is in start A. Yeah. Okay, now we can back down. Right, remember you have no time in party. You can't use any equation with time. So that only leaves you with second one should be. Can you go without please?
S to eta.
Huh? What's that?
S to eta.
Which one? Because that. Right, so as you all said, we use it. B squared is equal to u squared plus 2as. Final velocity is 0. Initial velocity was 50. Acceleration is minus 9.81. Right, minus why again, Shivish? Why? Why is the acceleration negative? It's still on the board. It's still on the whiteboard. Don't pay attention. Look on the screen. Why is the acceleration negative? Why? And it's going up. Right, and then solve where? Dexter, how much you got first? Huh? Anybody else?
I get 5.2 and I.
No, party.
Oh, 1.7.4.
127.4. 127.4, right? So let's work it out. Right? Divide. Everybody else got up? Yeah. Time taken to reach maximum height. What is the equation you're going to party?
You can think about it. You can think about that as well.
Right? So the one time to reach maximum height. Right? So as I said, we can use B is equal to U plus U. Final velocity is 0. Initial is 40. Gravity is minus 9.81. Yeah, they told you what to use. What's the next upgrade? What's the next option? Part C. The question told you to use S is equal to UT plus a half AT squared, but there's a next option. Work it out and see. So what is part 2 again?
The answer.
Yeah, 40.
5.09. 5.1.
5.1. Right. Work out part C and tell me what you all think is the second option. Work out part C and let's see what we got, right? Right. To be sure, you can message your answer. Let's see what you all got. Please have a question to call the DVD equation. You're plugging in the value. Equation of one. You try the question. And then tell you which equation to use. The part C in it, and it's told you what to use. So what is that? Right? What you? Right? I mean, I'm mistaken here. There should be 50.
That's what I'm saying. I was asking with you. It's gonna be fine.
That should be 50 on top there.
It's gonna be fine.
Right, so plug in the values and solve it. So plug in the values and tell me what you all got for part C.
Yeah, it's fine.
And there's a next way to get part C. Plug in the values for this. Where you go.
Get 12.9.
Yeah, I'll do just some, but I want you to tell me what you all got. Nah. It's a quadratic here, so.
Yeah. And next one,
Huh? So what's the next value? And the next value? 12.
So what did you find? That's 4.9 squared. So that's 15 even if
Right, those who are online, you can take a look at the board. So it will be S is equal to UT plus a half AT squared, right? Huh? Ah, something wrong there. S is 127.4. The initial velocity is 50. Right, the acceleration is minus 9.81 by t squared. Here again. That's all. Let's take this out. Right, this going up and down. All right, wait, hold here. For us to do this, you know what's wrong here, right? Besides that, they want the time taken. Divided by 2. No, but they want the time taken to go up and down. So, what will the displacement be? 200 and something. It will be 450. The displacement. What will the displacement be? It will be time taken to go up and come back down. Right? Remember, you went up to your maximum height and it come back down. Okay? It started going upwards first, so you can leave it as negative. Right? This is a maximum function, right? So check it and see now. Solve this quadratic, tell me what you get. Right? So is this, remember, this S is not distance traveled, S is displacement, right? Ah, and now Henry writes in 10.2. 10.2. Right? So the mistake that we made here was S is the total distance traveled or the displacement. They want the time taken to go up and come back down. So your total displacement when you reach here will be 0. Okay? And when you solve this in the calculator, you will get 10.2. Right? So anybody, what's the next way to do this? Instead of doing all of this, there's a shorter way to do it. Look at the answer in part 2, part B or whatever. Right, think about it. The time to go from here to here. The time to go from here to here was 5.1. So the time to go up and come back down, ignoring every distance, go up and come back down will be 5.1. No, the question told you to use them. Yeah, then you can do that. Huh? All right. So take a 5-minute break and we're going to start projectile motion. 20 minutes? It takes minutes. 3 minutes. But you have 6 minutes and we're going to start projectile motion. Right? Take a small break. Hey, only 6 minutes, huh? All right, let's start that there.
What else it does to protect that thing?
What's the last one, Mr. Shavish? I know you didn't part, or you want this? Everybody didn't part. So today we're going to start projectile motion and let us learn about the equation and explain how to get there, right? Oh, we can't, I see that. What about it? Right, all right, all right. Huh?
So I didn't. I like Oreo.
All right, so, what's up? All you gotta do is just go to the YouTube channel, cool name and go on the live. And then come back. Huh?
Yeah, anybody watch a video?
For now, yeah.
But no.
Name is cool.
I can send you later.
All right, so what's here now? So here's what we're gonna do. We're gonna change from moving vertically or moving horizontally to moving at a constant change in angle. All right. So if you had a particle like that, right? Particle had initial velocity u, and you shoot the particle at an angle to the horizontal. How will the particle move? The particle will move like that, right? So as the particle moving, what you will notice is that the particle has a change in displacement, of course. It has a change in displacement horizontally and vertically. Everywhere you go, right? So if you go up here, it will reach some maximum height and then start to come back down. Looking like it reach max height there. Right, somewhere here looking like maximum height, right? Right, so what you will notice is that at every single point here, let's say here, at this point here, right, it has a velocity here. That's a tangent. That's a VF. At this point here, it has a velocity that's a tangent and so on, right? Well, okay with that? Right. What is here? So as I said, the velocity keeps changing, right? The velocity changing. And as far as we remember, right? Once we have a component at an angle to the horizontal, it has what? It has two components, right? So this initial velocity is at an angle to the horizontal. So it should have a horizontal component and it should also have a vertical component. What will the horizontal component be? Right? Adjacent, so because the vertical component is what should be? Right? So the vertical component is u sine theta. Are you okay with that? Yeah. So at this velocity v here, and this is also at an angle. Watch it, it's at an angle to the horizontal, right? So it should also have two components. A horizontal component and a vertical component. Here is something interesting about the horizontal component. If something moving horizontally, right? If something moving horizontally, it is not affected by gravity. Why? Because gravity acts vertically, right? So this here is not affected, right? Is not affected by gravity because gravity acting vertically downward, right? But this particle staying horizontally, right? So this is not affected by gravity, but this is affected by gravity. So gravity will change the vertical component, but not this component. Everybody okay with that? So if you have the initial, just watch it first now, you're going to write up, right? So if we have the initial component something and we want to get B, how do we get B? B is a component of these two, right? B is the resultant of those two, right? So B is the square root of the vertical velocity squared plus horizontal velocity squared. All right, but again, we still need the horizontal velocity and we need the vertical velocity. But what did we just say about the horizontal velocity? It's not affected by gravity, right? So therefore, what will happen? It'll be the same all the time, right? This horizontal velocity not affected by gravity, so nothing affecting it. So therefore, the horizontal component of velocity is the same as the initial component, which is u cos theta. But the vertical velocity is affected by gravity. That's okay? So if it's affected by gravity, we could use any one of these to find its change. That's okay? Because this velocity, given the initial, is affected by gravity, and we can find this. You see that? Same thing here. It's affected by gravity and displacement, and we can find it. So if I ask you now, find the vertical component of velocity, right? We could use equation, let's use equation 3. Right? We could use equation 3, and I want you to notice this. If we use an equation 3, right? Vector quantity. I expect to understand if you know what it should be. Right? So if you have to use these equations, right? If you have to use these quantities in the equation, what you have to always make sure is that all of these in the same direction. Okay? So if I ask you to find the vertical component of velocity, this has to be acting, this has to be acting, and time has to be acting. It don't matter because time is a what? Scalar quantity, right? All of these here are vectors, not this, right? So therefore, if you have to find the vertical velocity, you need the initial vertical, which we have, and you need the initial acceleration vertically, which we have because of the gravity. So to find the vertical velocity, you need UV plus AB by T. That's okay? And we know what the initial component is U sine theta. Right? So this equation is really U sine theta. Because the particle going upwards first, it'll be minus G by T. Okay? Have the vertical component, have the vertical component. When you work it out, you square it and you get the velocity at any point in time. Okay with that? Right? Don't try to learn this off. Just understand how to use the equations of motion. All right? So at any point in time, I can find the velocity by using those equations there. All right, take that in first, copy it down. We're going to change now to find displacement. Copy it down. It's good to always, I know I'll give it in notes, but it's good to write this over and try to prove this something, right? United, you see in the right turn. United, see it? Naya, are you there? Oh, she's like, oh. Nikhil again, sure. So, nothing more? Wait, we didn't like. Wait, I've left. What's that? I think it's front next time. You did not see any what? I said that. All right, well, you'll help, man. Copy it up and we will do number one together. If you do it, go ahead. Right, I didn't break it down here, right? And then ask to find that we. So when you copy it down, we're going to do it together, right? Now you showing there still? All right, nice. Some answers, right? Right. Ready? So you want to find that velocity B, right? But we can't find B because we need the what? Vertical component and the right. So to get the horizontal component of velocity at that point, we need to get U cos theta. To get the vertical component, we need to get the initial vertical and acceleration and then work it out. Right? Oh, we don't have T. Sorry. Find B at T is equal to. Let's hope it work out. You know, sometimes when happen. 40 sine 50 is square. Yeah, let's do one side. All right. So let's see if we could find these two things here. So to break the question down, right? First thing we need is initial horizontal component. That will give us the vertical component, I mean the final horizontal, because those two are always the same. Then we need the initial vertical. What's the initial horizontal component, Shavish? That's where I get one, right, Shavish? So I can sleep tonight. Well, that's where I get one. What's the initial horizontal component? Who tell him? It's on the board. Sorry? U cosine theta. What is U? Huh? 40, right? So that's 40 cosine 30. Right? That's the initial velocity, and that's the angle. That's how much? 20 root 3. For those who have a sharp, well, round the top, right? Then work out the initial vertical. The initial vertical is what should be on a row. Toilet. 40 sine 30. How much is that? 20. So we have the initial and we have the, what do we need next? Well, no, we can't get V yet. We had to find PV. PV. Right? We had to find PV. Ariane, you okay there? Yeah. So we had to find PV. So we have to find the vertical velocity. Minus. Yep. It's whatever it starts with. All right, starting going up. Right, so we're using the minus. So we're using UV plus AB by T, right? Always remember, once you use the equations of motion, you're using them in the same component. If they're vertical, all vertical. So UV will be initial vertical, that was 20 minus 9.81 by 1. That will give us the vertical velocity, which is 10.1. And then go and find V. Now we can find V. Huh? All those B's here. Everything has to do with vertical here. Yeah. This is capital B, capital B. All those B's here.
So VH
VH is the same as UH because it's constant. So it's 20 root 3. I have to square it. And VB is 10.19 squared. Huh? UH is initial horizontal velocity. Right? And initial horizontal is the same as final horizontal. That's horizontal velocity constant. That's okay? What you got here? What you got here? 6.6. 6.6. Okay? No? Yeah? 36.1? 36.1, sorry. Online you're following? Again, any answers? See that? I don't know why we in this class. Beer. All right. So I want you to try to work it out and send something, right? Right, but we still have a part 2 to do. Find the time to reach maximum height. Hey, okay, let's plug in. Most likely. Most likely. So I need some help. Who's the pick on? Pause. I need some help, pause. Time taken to reach maximum height. What happens at maximum height? Right, we know that velocity is 0. What we gonna do all? Which equation will help us work that out? Right? Huh? It doesn't matter. 1 plus 2 is 2 plus 1. It doesn't matter. 1 plus 2 is the same as 2 plus 1. Yeah. All the horizontal components all the same. Part 2, yeah. Because so the problem I have in was I want to find time. So I have to use one of the equations here, right? Which one? Huh? Which one we can use? That was? All right. Help. Which one? Third one? We have final vertical velocity. What's the final vertical velocity here? What's the initial vertical velocity? 20. And we know the initial acceleration. Yeah. And so on, right? So here is 0. Here is what? No, here's 20. Vertical. Right? Remember, it's vertical. Every single thing here is vertical. Okay? So this is 0. This is what I said? 20. And here is minus 9.81. So T is how much? 2.0. Suppose I ask time for the whole journey. So what to do? Huh? Time for the whole journey is? Or use this. And S is how much? 0. Right? So you can use this and S is 0. You okay with that? Yeah? All right. I want to just show you one more thing here. Back to equations, right? So you all recognize I did not come and try to use these equations. I just look at the info I had and I use the equations of motion. So when you use the equation of motion, everything must be the same component. 1, 2, 3, everything must be vertical. 4, horizontal. Right? Because 4 does not have acceleration. So this is the only equation you can use for horizontal motion. Right? So actually, that's a good question, Shivish. Shivish, suppose I wanted to find the horizontal distance traveled here. Think about it earlier. Suppose I ask Shivish to find the horizontal distance they call R. How will I find R? Let's just say I wanted to find R. What to do? Yeah, which equation? 1, 2, 3, or 4? 4. Very good. So you use equation 4, yeah, and you use everything horizontal. No, let's talk about y, right? What did I ask for? Horizontal displacement, right? So if I get the horizontal velocity, I can get the horizontal displacement and time is a scalar. That's okay? Right. But Nikolai asked a question. Why can't I use? Why? Anybody can tell them why? I see you mumbling. Yes. Because this is vertical displacement. I want horizontal. So if I ask for vertical velocity anyway, then you come and use it. That's okay? Yeah. How I know it's vertical? Because I have acceleration in it. All right? And that's what I want you to catch. When to use the right equation. You don't have to go and memorize all that in proof. Use that and you'll get anything. Online? Yeah. Which one?
Well, the horizontal range, UT plus half
UT plus a half AT. And this is a horizontal range.
Yeah.
I'm still talking about, but we have a different way to work it out. Find out from the fast. Find out. I'm going to show you how to.
I think.
Yeah. That's probably done. So you had to read everything before you see the man have that time and make him man look bad. But it's technically correct. Because if you take off this, it becomes this. Right? Right, so yeah, so R will be equal to the horizontal velocity, which was 20 root 3 by T. And T was T was 2 by this. All right, so I'm glad I catch you all there with that little question. So now we can go into proving that the motion projectile. Right, what kind of equation is that? 2 by 0.4. 2 by 2.04, I mean. 2 by 2.04. All right, that's for the whole journey. For the whole journey, right? What's the answer? The answer is about
1.3.
141.3. Yeah. Okay. 141.3 online. Yeah. What somebody can always do in expression, you can show it around up, write the answer in the calculator and then run. All right. So now we have more than a bit something. But you can always keep in the figure. Right. So here's something I want to find out, right? I don't know that, right? Oh, come on. I'm moving right to school.
What's good?
Or sure than I think. All right. Quick question. Right. Here's the last thing that we have to do, right? The last thing we have to do is to show that this part paralleling. So we have to show that at every single point here, this will map out a quadratic. All right, so here's how you do it. Let's say at this point here, we have a vertical displacement y. That's okay? How do we find the vertical displacement? What's the equation there? Second one, right? And then if we have a vertical displacement here, we also have a. So how we getting the horizontal displacement? This one, and everything horizontal is here. Everything vertical is here, right? So horizontal will be velocity horizontally by time. Horizontal velocity is how much? Is u cos theta by t. Right? And you all said for y, to find the vertical velocity, I could use s is equal to ut plus a half at squared. Everything here must be horizontal, must be vertical. So initial vertical, that was u sine theta. Initial gravity, well, vertical, that would have been gravity by t squared. Huh? Yeah, gravity is minus g. Are you okay with that? Now, how do I make this look like a quadratic? Well, simple. All I have to do is get rid of t. Right? How am I going to get rid of t? Watch this here. If I make t the subject here, I'll get t is equal to x over u cos theta. That's okay? So I'm trying to get rid of t so I can get a quadratic. Okay with that? So since t is equal to x over u cos theta, we will get y is equal to u sine theta by x over u cos theta minus a half g by x over u cos theta all squared. Right? Yeah, you gotta be able to prove it, yes. Right? But don't kill yourself with the second alternative. All you have to show is this. Sine theta over cos theta, which is tan, right? But if you don't know that, someone will go like tricks. Minus a half g x squared all over u squared cos squared theta. All you have to show is that y is in the form of minus x squared. That's all. Right? Because a quadratic is what? A quadratic is ax squared plus bx plus c. So once you get this x squared, you'll finish. So y is equal to minus, I just put the 2 down here, right? Open brackets, minus g over 2 u squared cos squared theta by x squared plus sine on cos is tan by x. And this is of the form what? Right? Is the of the form ax squared plus bx plus. That's it. So at any point in time, they have to prove parabolic. All you have to do is to find the horizontal displacement, find the vertical, and plug one into the next. That's okay? In your notes, all this in your notes. All right, so in short, you do have to learn all of this. Just learn to use this properly. Okay? Minus g here, minus. Right?
Minus sign outside bracket.
Yeah. I just put the minus sign there to show you the maximum. 2u squared cos squared theta. 2u squared cos squared theta. Which market there, right? Okay, so that is the way you show projectile motion. Next day we do some questions, making sure that we can grasp this properly. Right, but before you go, I'm going to ask you one thing. If you have a particle, right, but the particle, it follows a projectile. But the particle, you're on top of a cliff and it shoot off horizontally. It will follow up path like that, right? Correct? If you shoot it off horizontally, it will follow up path like that, right? Yeah. And moving how here? Horizontally or vertically? So what will the vertical velocity be here? And moving horizontally, so what will the vertical velocity be? 0, no vertical velocity. If it initially moving horizontally, And initially it have no vertical flow. All right, so those are things that you have to consider when we're doing this next week.